Today we discuss about the cross product of two vector quantity. Or it is sometimes called vector product, because cross product of two vector is a vector quantity. Let us consider two vectors, a vector and b vector. So it is a vector and it is b vector, and angle between these two vector is theta. We consider this angle theta in anti-clockwise direction, therefore theta is positive. The cross product between two vectors a and b, it is denoted by a cross b, which is equal to mod a mod b sin theta into n cap, where n cap is an unit vector perpendicular to both a vector and b vector. Therefore, actually a cross b is a vector which is perpendicular to both the vector a and b. A cross b is perpendicular to a vector and a cross b is also perpendicular to b vector. Also, a cross b can be written as mod of a cross b. It is equal to mod a mod b sin theta. Again, b cross a, it is equal to mod b mod a sin minus theta. That is minus mod b mod a sin theta into n cap, which is equal to minus a cross b. Therefore, a cross b, it is equal to minus b cross a. It means the vector a and b, the vector a and b is not commutative with respect to cross product. Next, let us consider the vector a vector as a1 I cap plus a2 j cap plus a3 k cap, and the vector b vector equal to p1 I cap, b2 j cap plus b3 k cap. Then a cross b, it is equal to mod determinant of a cap, I cap, j cap, k cap, and we consider the component of a vector in the second row, a1, a2, a3, and component of b vector in the third row. So using this formula, we can derive a cross b. Now we have considered some other properties, that is I cross I vector equal to mod I sin 0 into since I vector and I vector both are along x-axis, so in this case we can say that k cap or j cap, any vector which is perpendicular to both I and I. So in this case we just consider here j cap, so it means 0 vector. Similarly, j cap cross j cap equal to 0 vector, and k cap cross k cap is also 0 vector, and I cap plus j cap is equal to mod I mod j sin 90 degree, and k vector is k cap is the perpendicular to I and j, and it is also unit vector, so you can write it is sin 90 degree into k cap. Therefore, I cap cross j cap is equal to k cap. Here mod I cap and mod j cap is equal to 1, as I cap and j cap both are unit vector, sin 90 degree 1, and k cap is a unit vector along z axis. Therefore, k cap is perpendicular to both I cap and j cap. Similarly, j cap cross I cap is equal to minus k cap. I cap j cap cross k cap is equal to I cap. K cap cross j cap is equal to minus I cap, and k cap cross I cap is equal to j cap. I cap cross k cap is equal to minus j cap. So we can remember this formula from this thing, that is, we consider here I cap, here j cap, and here k cap, and we give the direction clockwise here. Therefore I cap cross j cap, it is equal to k cap. Similarly, uh, j cap cross k cap, it is equal to I cap, and k cap cross I cap, it is equal to j cap. Now for any three vector, a vector, b vector, and c vector, a cross b plus minus c vector, it is equal to a cross b vector plus minus a cross c vector. So it is actually called left distribution law. Similarly, the right distribution law is as follows for the vectors a vector, b vector, and c vector. A plus minus b vectors cross c vector, it is equal to a cross c vector plus minus b cross c vector. Now we evaluate area of a triangle using cross product. Let us consider a triangle A, B, C. Here it is a vector, it is b vector, and consider it is c vector. Then the area of the triangle ABC, it is equal to half of mod A cross B, or it is equal to half of mod B cross C, or you can write down it is equal to half of mod C cross A square unit. Now we prove this formula. For that, we draw a perpendicular line from a point A to the line BC. It is P point, and AP is perpendicular to BC. Therefore, the angle APB, it is 90 degree, that is pi by 2. Consider the angle ABC, it is theta. Therefore, with respect to the angle theta, AP is perpendicular, and since the angle APB is 90 degree, therefore AB is hypotenuse. Therefore, AP by AB, it is equal to sin theta. This implies that AP equal to AB sin theta equal to, we know that AB mean mod A vector into sin theta. Now we know that area of the triangle ABC, it is equal to half of BC into AP. Here BC is base and AP is height. That is, the area of the triangle is equal to half into base into height. We know that BC is equal to mod B, and it is mod A. AP is equal to mod A sin theta, which is equal to half of. So mod A mod B sin theta mean we already know that it is equal to A mod of A cross B, this square unit. Next, we can also evaluate the area of a parallelogram if the adjacent side vectors are given. So consider a parallelogram A, B, C, D. AD vector, AB vector, BC, DC. We consider let AB vector equal to small a vector and AD vector equal to small b vector. A vector, then DC is also a vector since AB and DC are parallel. Okay, it is, we have considered AB vector is equal to, and AD vector is B vector as AD and BC are parallel, therefore AD BC is also B vector. Now we join P and B point, therefore the area of the triangle ABD equal to half of A cross B vector using the previous formula, and therefore the area of the parallelogram ABCD is equal to 2 into area of the triangle ABD, that is mod of A cross B square unit. Therefore A vector and B vector are the adjacent side vectors of the parallelogram ABCD, then the area of the parallelogram ABCD is mod of A cross B. Next, also we can evaluate the area of the parallelogram if the vectors, diagonal vectors are given. If the diagonal vectors AC is x vector and the diagonal vectors DB is y vector, then if AC is equal to x vector and DB vector is equal to y vector, then area of the parallelogram ABCD equal to half of mod x cross y square unit. Now we can prove this formula in few simple steps. As we know that x vector is equal to a vector plus b vector and y vector is equal to a vector minus b vector. Therefore, x vector cross y vector equal to a plus b vector cross a minus b vector, which is equal to a cross a minus a cross b plus b cross a minus b cross b. We know that a cross a is a 0 vector, and also minus a cross b, b plus b cross a is equal to minus a cross b, and b cross b is also 0 vector, so it is equal to minus 2 into a cross b vector. Therefore, half of mod x cross y vector equal to half of mod minus 2 into a cross b vector, which is equal to mod a cross b vector equal to area of the parallelogram ABCD. Area of the parallelogram ABCD. Therefore, if the adjacent side of a parallelogram is small a vector and small b vector respectively, then the area of the parallelogram is mod a cross b, and if the diagonals are x vector and y vector, then the area will be half of mod x vector cross y vector. Now we solve few important problems from cross product of vectors. This question is very important for higher secondary student. A vector and b vector and c vector are given. Find a vector d which is perpendicular to both a vector and b vector. So first of all, and c dot d is equal to 18. So first of all, we evaluate a cross b. A cross b equal to I cap, j cap, k cap, then 1, 4, 2, 3, minus 2, 7. Now we expand this determinant value with respect to first row. 32 I cap minus j cap minus 14 k cap. B vector is perpendicular to both A and B vector. Also we know that A cross B is perpendicular to A vector and B vector. Therefore D is parallel to A cross B. Therefore D can be expressed as the scalar multiple of A cross B. Therefore let D vector is equal to lambda into A cross B, mean lambda into 32 I cap minus j cap minus 14 k cap. Now it is given that C dot D vector equal to 18. This imply that lambda into 32 into 2 plus minus 1 into minus 1 plus minus 14 into 4, it is equal to 18. So this imply that lambda. Now we discuss a very important relationship between dot product and cross product. So let us consider two vectors, small a vector and small b vector. Then A dot B equal to mod A mod B cos theta. So it is equation number 1, and mod A cross B equal to mod A mod B sin theta. Now we squaring and adding equation 1 and 2. Then we get A dot B whole square plus mod A cross B whole square equal to mod A square mod B square cos square theta plus mod A square mod B square sin square theta. So it implies that A dot B plus mod A cross B whole square equal to mod A square plus mod B square. So if you take mod A square and mod B square common, then it is sin square theta plus cos square theta. So we know that sin square theta plus cos square theta is equal to 1. Therefore A dot B whole square plus mod A cross B whole square equal to mod A square mod B square. So this is the relationship between dot product and cross product up to